Hello everyone, this is the video lecture for College Algebra, Math 1414, Section 1.6, more solve for x. More. Alright, some of these problems are very difficult, so I would say that this is the more difficult section with solve for x, and that's the primary purpose, is for me to show you how to get started on these guys. So I think that this one here says factor, then solve, or something like that. That's what I got. So let's do it. I'm going to factor. Yeah, I'm not going to move this guy over and start canceling. Man, I sure felt like I wanted to do it. But that's not the correct way. We have to factor. What do these guys have in common? It definitely X's. They got two X's in common there. But do they also have a 6? That would be really nice. 96 divided by 6 is a 16. So yes, they also have a 6 in common. So we could do this. Cool, cool. Can I factor this? And the answer is yes. That ends up being a -4 and a +4. Isn't that cool? Of course, what two numbers multiply to make a 16? 4 and 4, and they add up to make a what? A 0 in the middle, 0x. But we already covered that in the last previous section somewhere. Cool. I don't know if this is actually what they're wanting or not, but I have it boxed in, so that's a good idea. Solve for x. If there's no numbers with it, that does not count. We already talked about that in the last section as well. Divide by 6 on both sides and all that kind of stuff. Even with an x squared, you're just saying x times whatever, blah, blah, blah. The idea is that, is there any numbers really attached to this thing like this and this here? Nope. So therefore, it's a 0. You just have an x by itself, even x squared, your answer is 0. These guys are a little bit easier for us. We got 4 and a -4. And so that is my final answer there. Sorry that my 4s don't look so good. All right. Again, these are tougher problems. That wasn't that tough, but, well, you know, it's going to get a little bit more crazy. 3 minus 2x, and I'm going to have the square root of that is equal to x. So it definitely gets more intense than this, but I'm seeing a square root, and I don't really see another way to solve this besides perhaps just squaring both sides. Square both sides, and what that does is it cancels both of those things and leaves me with this guy. Now wait! I square both sides. Shouldn't I put a plus and minus in there? No, actually not. It's when you square root both sides. Square root of 4 or something like that. If you square root both sides, then by all means, plus and minus. And that's good. But that is not what we did here. We did not square root, like we did not put a square root of our own in there. We put a square in there. And if you square both sides, you're okay. You don't have to do a plus minus. It's just positive. Just interesting little side note, I guess. Okay. I'm going to take this right here, toss it to the other side. And so I just change your signs, basically. I wonder if I could factor this guy now. So what two numbers multiply to 3 but add up to 2? It's going to be a 3 and a 1. If I had a actually, if I had a positive 3 and a -1, I should yield a positive 2 in the end. And those are my two answers, -3 and a positive 1. Cool. All right. They say it's wrong? What? Cannot believe it. I did all the math right. Okay. If you ever get something like this, you need to double check. Yep. Dirty words there. I have a little reminder of my own, if you don't mind. I got 2 answers, so I need to double check. I ought to do it twice. Because you have a duo, maybe a pair. See what I'm trying to get at here? There's 2 of them there. A couple. There are a couple of answers, so therefore 2 of them, double check. That's what I'm trying to get at. So I got x is equal to -3, and I want to see if this works with the original. Let me rewrite the original. Looks like that. I'm going to plug a -3 in here and see what happens. Negative. Negative. Two negatives make a positive. I got the square root of 9 is equal to -3. Does 3 equal -3? Well, it's awfully close, but no. The other one was a 1, right? Let's try that one. Trying to extend that there. Plug it in. We got 3 minus 2. So 1. The square root of 1 is a 1. Yes. So this is definitely my answer here. My one answer. I'm going to say only that answer because this one just did not work. We tried it. It didn't work. So if you got two answers, go ahead and double check. That's my key note for that problem. 1, 6, 17. I got x minus the square root of 2x minus 2, then equals a 5. Now, this problem here is getting increasingly harder. The next one after this supposedly is even more hard. So we've got to, I don't know, figure out some kind of strategy with this problem, and maybe the other ones that we're doing here too. If you go back to the last problem, what did I do? I squared both sides. That's going to be, I guess, the way out of the muck. To get out of the swamp, we have to square both sides. But if I did that right now, I'm going to get a huge mess. Oh, I know what you're thinking. Oh, well, you distribute your square, and then you just got this guy. No! Don't even go that far. Very bad. Bad math. You cannot distribute a square. It just doesn't work like that. What you're actually doing, in case you were actually thinking that, not trying to yell at you, I'm just, saying. What you got when you square, you got this, which means FOIL, which means, I mean, this is one way to do it, but I will not be doing that right now. I think there might be a better way. Squaring both sides is important, but maybe not the first step. I don't know. What if instead I add this square root 2x minus 2 to both sides? Now, I'm doing this, I know it's a little bit clunky, but I'm doing this for a purpose, and I'll show you why. And I'm going to minus 5 on both sides. So I got x minus 5 is equal to this big old square root thing here. Now I'm going to square both sides. And that cancels immediately with the square root. Immediately. So here, again, we have two of these entities. And then here we only got the one. Here you're supposed to FOIL. But notice this foiling is so much better than the previous attempt. Minus the 5x, minus the 5x, plus 25. I'm going to minus the 2x on both sides. Combine these like terms together. I'm also going to add the 2 to both sides. And combine those like terms together. X squared, I got a negative 12x and a positive 27. Yep. Can I factor this to solve for x? And the answer is yes. What two numbers multiply to make a 27 but add up to 12? I think it's going to be a 9 and a 3. Negative 9, negative 3. Make a negative 12. Yep. So my answers are x equals 9 and x equals 3. Awesome. Very good. Turn the page. Gosh, I hope you're not hating me over this, but it does happen. I mean, I'm just emulating what my math would do, or what I would do on the homework. Two answers. We got to double check. I know. It's just like, man, didn't I do enough work already? So x equals 9. Let's go ahead and plug that into the original. And I mean the original. Don't try to skip something or use something else along the way. Plug it back into the original. Let's see what happens. I got a 9 minus the square root of 2 times 9 minus 2 equals 5. Here I got an 18 minus the 2. Thankfully, that made a pretty 16, which yields a 4. I'm already writing a 4 because you know I'm thinking that. And so then we got 5 equals 5, and I like that. That's good. Okay, what was the other one? Was it 3? Yeah. 3 minus the square root of 2 times 3 minus 2. Well, you already know it's not going to work because this one worked and it was both of them didn't work. We already had tried that with our first attempt. But come on, I'm the math teacher. I got to actually do the math, don't I? Notice that this looks really close. Do you see that? Except for that 5 doesn't look very good. You get the idea. Roman numerals, they're way better. So, -1 does not equal a 5, and therefore that doesn't work. Okay. So it's only going to be the 9. So, like, in the end, in my math lab, they say x equals what? You put a 9. And that's it. You walk away, and you're good to go. 1, 6, 23. I've got the square root of x plus 5 minus the square root of x minus 2 is equal to 1. It seems like it's getting increasingly harder. I mean, first off, we had the one square root where we just square both sides and it was okay. The next one after that, we had to simplify and then do it. It still wasn't very pretty. What do I do here? What do I do here? I even wrote down in my notes here, it says tough. It says tough. I'm going to do the best I can. And right now, that's going to be square both sides. Now, I know you're not going to like this. I know that because I don't like this. If I don't like it, you're not going to like it either. But I don't make the homework. Just want to make sure you know that. I just administer the homework. It's not my decision. I think it's good homework, honestly. It's just, there are tough problems, and, well, don't blame me. So, anyways, what do we do here? I got 2 of them. Can't this just distribute the square? No. I have to FOIL this thing out. Little moon shape. See the moon? Someone showed me that. I was like, wow, I've been drawing a moon. This square root times this square root. Now, you know what? I'm going to do it the really, really, really slow way. But these square roots actually are going to cancel, not to make a 0, but to make the original on the inside. We'll do that here in a second. You do not need to go as far as I go on each one of these problems. If you know what you're doing, or you kind of get the idea, skip ahead. You can pause the video at any time. Well, you already probably know that, since it's a video. I'm acting like it's a classroom, except for I'm not asking if there's questions, because I do that a lot in class. But if you do have questions, you can, of course, email me or message me at any time. I still didn't type it right. Do you see over there? Hold on. I don't have a very good eraser. I was talking too much about other things. I should have been paying attention to the math. Thankfully, 1 squared is just 1. So that's at least one good thing on our side. Notice again, I got 2 negatives. So we'll make a positive right here. But this is just a mess. And so this right here actually combines to make something much easier. When you have 2 square roots, it's basically like half power, and half power makes a 1 power. Or basically just itself, or I would say the inside. These are actually the same thing. But I can't just, you can't eliminate them because they're both negative. I'm going to put a 2 in the front. And hopefully we can do something with that here in a minute. Same thing over here. They simplify down to, well, itself, the inside. You could put parentheses, but it might be a little confusing with all this stuff going on. I would rather not right now, just because I'm going to combine like terms. I want these guys to combine, and I want these guys to combine. So combine like terms. I got actually 2 x's, and then I got what 3? Got my big old square root thing, and then it equals 1. I am actually going to add this whole thing to the other side. Simultaneously, I'm going to subtract this 1 to the other side. So when I minus 1 on both sides here, See how I'm going to get here a 2? When I move all of this with the minus sign, I'm going to move it all to the other side. Remember, I'm going to add it to the other side. Therefore, it's going to be a positive 2x. I'm sorry, positive 2 square root of x, blah, blah, blah. I'm not going to say it every time. You get the idea. So I moved it over. Divide by the 2 on both sides, just because I think that's going to be an easier step. And we actually get something very pretty over here. See? Look at that. It's not pretty on the other side, though. So we got to go and do more math here in just a second, and the next step is going to kind of get us out of the swamp, I hope, here in a second. But I'm going to say that, yes, there are a couple problems in your homework where it's going to take a long time to get there, a lot of math to get there. Look what we've done so far. I honestly, just between you and me, I start to wonder if it was worth it. Not that I shouldn't be doing it, but that, like, I've gone so far and I haven't seen my landmarks yet. Maybe I should turn around or try something else. It's a very typical mindset where if I am not getting the right answer within a couple steps, if I'm not seeing the goal here in a couple steps, then maybe I was doing something wrong and I need to try something else, you know? Well, there are a couple problems where it does take a lot more steps. So, you know, just let's keep on going. I'm just saying, you just watch out. It's okay to keep going a couple extra steps. You're in College Algebra 1414, not 1314. So there's a little bit of difference. It's a little harder here, honestly. So I am going to square both sides. And the reason why is because I see those square roots. They're sitting by themselves. Hopefully this will do something. And so, do you remember me saying something very particular here? I said, do not distribute the square. That is so true. You don't distribute the square between a plus sign or a minus sign, but here you do. I know, right? It's like I'm breaking my own rule. Well, this is something that we do all the time. Let's just say I had 3x all squared for a second. You can see the result is going to be a 9x squared. The 3 is squared and the x is squared. Both of them get squared. Now, I can't say that about x plus 3 squared. That's not going to be x squared plus 9. No, that's x squared plus 6x plus 9. Because we have to FOIL it out. When you have a plus sign in the middle, you have to watch out and do the square the proper way, like what we're going to do right there. But if it's just two entities multiplied by one another, I guess you could distribute the square. I don't like saying that, but you get the idea. I'm just doing proper math here. Both of these square roots get a square. And if you're like one step ahead of me, you already know I don't really have to write this step here because the square roots and the squares cancel. I mean, it's basically, I'm just doing that. There we go. Whew. I do not have any more square roots. Yeah. After about like 50 steps. So now, got to keep simplifying. This right here, again, is a square factor, so we have to FOIL that out. And the funny thing is, on the other side, it looks like we got two factors, which we have to FOIL out. X squared plus 2x plus 1. On this side, x squared minus 2x plus 5x minus 10. Let me just simplify that one side real quick, like. I got a plus 3x. You know what's interesting? What if I wanted to combine like terms, like minus x squared on both sides, and wow, they just go away. That is so nice. Thank you, my math lab, for giving me something easy at the very end. Okay, I got an 11. And is it right? Turn to page. Yeah, it's right. You're so expecting me to say, no, it's wrong. Double check. Well, hold on. I got a question for you. How many answers do we have? 1. Do I have to double check? Not going to say. So 1.6.33, yeah, that's your answer. I got x minus 2 all to the 5 halves is equal to 32. You know what? Nah, I'm going to let y'all... I'm playing. Of course I'm going to do it. It's just crazy, isn't it? What is this problem? Where am I going to use this in the real world? That's just... I'm just joking. I'm just joking there, okay? You're going to use this every day in your job, right? Because that's what you're here for. Snicker, snicker. So, I wonder what we're going to do in order to cancel this stuff. I need to cancel this guy. Like, let's just say that I had a square root here instead. What would you do? How would you cancel this stuff? You would square both sides, right? Square and square root cancel. Well, let me rewrite something for you. Let me just rewrite what this would look like using exponents. The square root is technically a 1/2 power. And the reason why we're doing a 2 power is because 2 times a half, right here, makes a 1. And then the 1, you don't even need parentheses because the 1 power is just itself, so we're good to go. The point that I'm trying to make, I don't really care about this side here, the point that I'm trying to make is that these guys here are actually canceling because they're like fractions and they multiply to a 1, that kind of thing. That's the behind the scenes that we don't really think about all the time. So what about here? I want that same process. I want to be able to cancel the 5 halves if I multiply it, and I'll make a 1. What if I multiply it by 2/5? On both sides, of course. Notice what happens. We got 10 in the top and 10 in the bottom. 10 over 10 makes a 1. The other side's crazy. But at least this side's pretty easy. Again, with a 1 power, you do not need the parentheses anymore. So that's what I'm doing. I'm kind of canceling it, I guess you could say. There's a couple other explanations you can go with, but 5 halves, 2/5, they cancel, leave a 1, we're cool. So we like this guy. Much easier than what we were working with originally. Now, I wonder if this here can be simplified down. What I'm going to do is I'm going to use my calculator right quick. And I have an old TI. Maybe you have a new TI. Maybe you have a cool Casio. Blah, blah, blah. I typed that thing into, again, Desmos, GeoGebra. You can use whatever. So, and I get a 4 out of that thing. Isn't that cool? That's so nice of them. A 4. I don't know what this is. Good thing that there's calculators out there to help me. I mean, of course, we could do it by hand, but that's not the point here. The point is that we got the answer, and we're good to go. Next problem. So, of course, I look these problems over before I start the recording. These next 3 problems are very similar. And they're difficult. I would say probably all of this section is going to be difficult. Okay, they say use substitution. Now, I know the word substitution. They mean plug it in. What they're wanting here, though, in my math lab, they say u is equal to blah, blah, and then they got a big old blah, and that's it. Go on, figure it out. So, seriously, though, let's just pause for a second here, okay? If you do see problems like this, and you don't know what they're wanting, you don't know the format that they're wanting, how can you even know what to start doing if you don't even know what the goal is, right? Words aside. I would put in, just as me, I'd put in a 0 for both of them and just hit submit. Submit, submit, submit 3 times. And they'll show you what the answer looks like. Okay? Here, I'll show you what the answer looks like. I'll give it to you. And then what I'm going to say, I'm going to actually do this here in a second. But what we can do now is I can say, I wonder, I have to include a 0. I wonder if, and then I start making my own conclusions. It's not like we're trying to cheat here. I just want to know, what am I supposed to do? So what they're wanting is they're wanting to substitute something into this to make it, rewrite it to make it a little bit different. Okay? Think about this for a second. This right here, solve for x. Come on, solve for x. And you're like, I don't know, because I don't know either. So what they're wanting to say is, can we simplify this down to something that maybe we can, solve for? I don't know. So in these particular problems, when they're saying use substitution, I'm using all kind of colors here, I'm going to look at the middle term. I'm going to write that down. It's very important. The middle term. The middle term is telling you what you should be your substitution, your use substitution. And this is because this is a quadratic form. I'm going to actually write that out. Quadratic form. Now, normally I say quad form for formula. It's not form as in formula. It's just form. It's like shape. It's a quadratic shape. It's a blah squared plus a blah plus a number equals 0. It's a particular shape. It's an ax squared plus bx plus c equals 0. It's this particular shape. That's a shape here. In order to get that shape, I need this right here not to be x to the 4th, but x squared. Now, how do I do that? Hey, I don't need this as an x squared. I need this as a single x. Well, how do I do that? I'm not going to square root it. No. I'm going to say, well, what if the middle term here was just a u? They say u. If that's the case, if I have this term right here as a u, well, then I could just write u right there. See, 29 minus u. Or, I'm sorry, 29u. So, okay, cool. I have x squared is equal to u. Well, I have x to the 4th. How do I make that into something u-ish? Well, what am I doing from here to here? Aren't I squaring both sides? So it's u squared. See what I'm saying there? Here's my quicker trick. Let me rewrite this thing, and I'm just going to get down to the meat and taters side of things here, okay? That's just like right down to it. So step 1, look at your middle term. Put that in the U box. Step 2, you always got something squared, and then you got the rest of it with something else, and then you got that 100. Well, that thing that goes inside there is a U. I mean, technically it is an x squared, but they're not wanting you to write that right now. It's always got this form, this shape. That's how you get it done really quickly. The thing is, though, is that the point is to make this right here solvable. To make it better, I guess you can say. Now, I don't like the letter U, but we'll figure it out. I want to solve for U. Can I factor this thing? What two numbers are going to multiply to the 100 but add up to 29? Well, 5 and... No, not 5 and 20. What about 25 and 4? 25 and 4. Those work. So I like this. This is good. But hold on. Hold on. Isn't U equal to something not too bad? Right here. U is equal to x squared. What if instead I were to have x squared written in there? Because, I mean, we need to solve for x, not for U. So I'm now saying, I think I've seen this perfect square stuff before. What two numbers multiply to make a 25? 5 and 5. What about there? What two numbers multiply to make a 4? 2 and 2. And so then I can just list off my answers like this. Those are my answers. Let me just put them all in one big box. The reason this problem took so long was because I was trying to explain it. trying to. When it comes down to it, just recap right quick. Look at the middle term. There you go. You're always going to have this format. So instead of whatever you had, just put a u squared. Instead of whatever you had, put a u. That's it. And you solve. Next problem. So 1, 6, 47. I got x to the negative 2 minus 3 times x to the negative 1 minus 18 equals 0. Huh? You know what's even better than all this? I didn't actually do this on my paper. I definitely want to do it with you at least a little bit here, if not the whole thing. What is going on? Well, it's supposed to be in a quadratic form, and so I'm supposed to find out somehow to make it into a form, ax squared bx plus c equals 0, something like that. Well, we're going to just do it straightforward. Take the middle term. You're going to put it in here, u equals x to the negative 1, whatever that is. And my format for this is always going to be a u squared. There's a 1 right there in the front, so 1. 1u squared minus 3 times u minus 18 is equal to 0. You don't even need to have the 1 right there. There you go. Make sure to include the 0, the equals 0 part. That's actually important. Oh, man. So I in my last problem, I said you need to include the equals 0, but then on my other two problems, I just left it off. So I'm pretty sure you need to have a 0 there somehow, okay? So watch out. If MyMathLab provides an equals 0 right here, then you could just erase it. Either way, need to have the equals 0 somehow. This part's not hard. What we're getting at right here, by the way, what is this thing right here? This is x to the negative 1 squared. I'm splitting that negative 2 up into negative 1 and 2. Well, notice that this inside right here is the same as this term right here, which is my u. It's that term squared. That term squared. And then we have the regular term, constant equals 0. Okay, cool. Now we need to actually solve it. This is where I did not do any more math, so if I get it wrong, well, you know, I'm doing best. I hope I don't get it wrong. So I know I can factor this thing. What two numbers multiply to the 18 but add up to a 3? To me, it sounds like a 6 and a 3. I think a 6 and a 3. So minus 6 plus 3. Sounds about right. So I got u equals a 6. And then I got u equals a negative 3. Two answers there. So I put those in. Because we need to solve for x. It was very nice that we had u's, but not x. So let's go and, plug it in here, substitution stuff. X to the negative 1 is equal to 6. X to the negative 1 is equal to 3. I have to solve these now. And this is where I'm lost. What are you talking about? X equals x to the negative 1. What is that thing? Well, if you go way back, I'm pretty sure this is way back, we're wanting to rewrite this as a fraction form. This is actually just 1 over x. Now, there's nothing else I can really say besides you got a negative in the power, you flip it, make it a fraction kind of thing. It's just kind of like a formula, rule. So x to the negative 1, it's 1 over x. Got a negative power, it flips it. Can I solve for x now? What if I use a different color, what if I multiply by x on both sides? It's a little strange, but I think it'll work. Cancel those guys out. 1 is equal to 6x. Divide by the 6. X equals 1/6. Same thing on this side. What I'm actually doing is I'm flipping these guys. I'm switching them. So x equals 1/3. Two answers. I should probably double check, but, well, I'm lazy right now, so there you go. Should be good. 1, 6, 53. I got 2x minus 9x to the 1/2 plus 10 is equal to 0. Now hold on here. Hold on here. I thought that this was supposed to be an x squared with an x and then a whatever, blah, 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 right? You're messing me up, man. Shouldn't I, like, flip these guys and blah, something or other? It's a strange one. It is. But I'm going to go with the same format, the same formula I've done every time. Take the middle term. Put it in this box. 2u squared minus 9u plus 10 is equal to 0. I'm talking patterns here. That's all it is. I'm saying 2 times u squared. This is always there. Always. I got a minus 9. Always a u there. And then I got my plus 10. Equals 0. Always the same thing. You're always going to have a u squared. You're always going to have a u there. Because it's the quadratic form. I don't really know if that actually made it easier. I mean, there is a 2 in the front, and that just disgusts me. But surely there's a way to solve factor? What 2 numbers? Multiply to make a 10, but somehow magically make a 9 in the middle? I don't know. Because there's a lot that make a 10. 2 and a 5, 1 and a 10. Well, that's not a lot, I guess. There's a lot of possibilities that could happen, and I would be double-checking myself a whole lot. And there are certainly ways to solve this. But what I'm going to do is I'm going to do that. It's called the AC method. We already did this in another section. I'm going to do the 2 times the 10 to make a 20. And I'm going to list out all the factors that make a 20. So 1 times 20, 2 times 10, 4 times 5. I'm wanting to see if I can take some of these and add or subtract to make a 9. And sure enough, these guys here should do it. So then I got a 2u squared. I'm going to do minus 4u minus 5u plus 10 is equal to 0. Notice what I did. I took that 9u and I made it into these guys. Now, we did this in another section. It shouldn't be too foreign. But the point is that I'm trying to make this the same. This is a 9. This is a 9. Combine like terms, you get the same thing, right? Not doing anything wrong here. But I did this on purpose so that I have factor by grouping. And if I had the 5 on this side and the 4 over there, it would still work out. It would just be a little bit more ugly for a second. Thankfully here with the 4 and the 5 in the correct spot, it makes it look really pretty. Notice that I have to pull out a minus sign here somehow because you must have these the same. They have to be the same. I have none of this on my notes, guys. I just basically said, all right, well, figure it out. These notes are from last semester, if you're wanting to know. I think they're great notes. But that's why a lot of times I don't remember what the problem looks like or something. I think that's for our benefit. That way we're not cheating. So, factor by grouping, we've done this a lot. Take your 2 factors, move them to the front. Whatever's left over, there you go. And so then I can solve for u equals 2. And over here, I'm going to add the 5 and divide by the 2. 5 halves. But that is not what they're looking for. As you remember from the last problem, I need to go back and solve for x. And x is this, u is this x to the 1/2. So I got x to the 1/2 is equal to 2. X to the 1/2 is equal to 5 halves. You know what's funny about this 1/2 thing? That's just a fancy way of saying square root. How do we get rid of a square root? You square both sides. And when you square both sides, you do not put a plus and minus, just a positive. That's it. Same thing over here. Square both sides. That means the 5 is getting squared and the 2 in the bottom's also getting squared. 25 over 4. There's your two answers, both positive. Okay. Whew. Yes, you should double check. I know. I'm not going to double check. I'm just going to write here double check, and you can go and do that for yourself. Okay. 1, 6, 63. I've got the absolute value of x minus 2 is equal to 4, and they say solve for x. So, okay, hold on. Absolute value. Surely there's some kind of way to get rid of that thing, right? Do I square both sides? No. But there is an easy way that I approach this with. So there's two ways. You can say wherever there's an absolute value, just remove it and put a plus and minus there instead. That's the easiest way to solve these problems. Right there. You had an absolute value, just change it to a plus and minus, and then just, solve. Now, this looks a little bit strange, of course. You would have two separate problems at this point. You got a positive x minus 2 is equal to 4, and then you got a negative x minus 2 is equal to 4. Distribute your negative. This guy doesn't matter. Solve, 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 etc. Cool. And that's basic, and we would get the answers, and that's fine. You get 6 and negative 2, whatever. I want to do it one different way. I think this is the most straightforward way. I would say this is the recommended way if you don't want to be curious with it. But there's a better way, in my opinion, because I like plus minus. I like to just kind of hang out with them all the time on the weekends and stuff like that. And this is just a lot of work here. So what if instead, and this is again unorthodox for a whole second here, what if instead I put the plus and minus with the 4? I'm doing the same step here. Every time you got an absolute value, just go ahead and put a plus and minus in the front. But I'm putting it over there. In a way, I'm trying to move this guy over, but now he's a minus plus, but it doesn't really matter because you're going to get two answers anyway, so I'm going to do a plus minus, yada, yada, yada. It doesn't really matter. But this makes it easier because I'm going to just simply say add 2 to both sides. And then I got two different answers, and they're super easy. I got positive 4 plus 2 makes a 6. And then on the other side, I don't know if you knew I could do that. I got a negative 4 plus the 2 makes a negative 2. Cool. There's your two answers. And actually both of them work. That's nice. Still more to go. 1, 6, 71. So I got 3 times the absolute value of 6 minus 3 halves x plus 7 is equal to 34. Solve for x. I would say try to simplify the outside as much as you can first. So 34 minus 7 is a 27. Divide by the 3 on both sides. And I get a 9. See the absolute value? And so then I got plus or minus 6 minus 3 halves x equals 9. And you got your two answers and so on and so forth. I'm going to, this is just me now, I'm going to do my little handy trick of putting the plus and minus on the other side. Again, we've already said that it's not wrong. I just don't normally do this. I normally say whatever was absolute value, I put a plus and minus next to it because that's the point of what's going on. Like if you had a plus x and stuff over here, it really wouldn't just be this 9. It would be a whole mess of stuff going on. So just be careful. Be careful, okay? Keep it like this. If you're unsure, keep it like that. But I'm going to do a little bit of adventurousness, if that's a word. And then I'm going to divide by this negative 3 halves. Now that's very, very strange, but it does work. What it looks like in the end, because you're dividing by a fraction, you're going to flip it to make it a negative 2/3 times plus or minus 9 minus 6. this is where I start to split off into two different answers. Because at this point, we just say it's a positive 9 minus 6. Do the math. Or it's a negative 9 minus the 6. And you do the math. Here on the inside, we got a 3. 3 and 3 cancel right there, making a negative 2. So that was pretty easy. Here we got a negative 12. 3 and the 12 actually is going to make a 4. 2 negatives make a positive. 4 times 2 is it 4? Okay, hold on. Whoa. I messed up here. 9 and 3 make a 12. 9 and 6 makes a 15. Oops. Okay, well, you know. Good. That's why I have my notes with me, right? So I can double check myself. 2 negatives make a positive. The 3 and the 15 make a 5. 2 times 5 is 10. Okay. Always watch my videos to the end. I think both of those answers work. It's good enough. 16109. I got little p is equal to 2.4 times the square root of t plus 32.3. P is a percentage, and t is the years after 1970. And they have this chart on the side. It looks kind of like this here. You got men, you got women, and somewhere right around here at 2000, we have 55 and 45. Okay. That's just for later. They say use the model. Ding, ding, ding. Ding, ding, ding. On the year 2000 and compare it with whatever. Okay, so we're starting at 1970. We're going to 2000. So t is equal to 30. I'm going to plug that in. I got 2.4 times the square root of 30 plus 32.3. All these decimals make me feel like a calculator is appropriate, and it sure is. 45.4453%. My math lab wants you to round to the nearest whole number. 45%. Oh. Okay, hold on. Back up. Okay, hold on. No. My math lab, I'm going to explain myself. My math lab wants 1 decimal place. That's my bad. Okay. They want 1 decimal place, but you know how I went through my notes, but I didn't go through them well enough. This is part B. Part A was just grabbing this number from the graph itself. That's okay. We got it. We figured it out. Watch the video to the end. So, so part A, they're wanting just the number from the graph. Part B, we do the math, and they want 1 decimal place. And I think that's all for that side of things. Sometimes they say compare and under or overestimate. I don't think they have that here. Part C, they say when will 57% happen? And they want to know in what year. Well, P percentage right there is 57. I believe they want it as a whole number. 57 is equal to 2.4 times the square root of t plus 32.3. And then we solve for t. First off, I'm going to minus the 32.3 to the other side. And I'm just looking at my note. Oh, and I'm going to then divide by the 2.4. Apparently, I just kind of skipped a step there. So all this right here ends up being a 10.291667 is equal to the square root of t. To get rid of the square root, we square both sides. And when you square by sides, you do not need a plus and minus. I got 105.9184 years. It's not what they want. They want you to add 1970 to that to find the year. 2075.9. I don't know. What is that? October, November? Well, maybe August, September, something like that. Regardless, they want you to round up apparently, so just round. Maybe that's November. Yeah, I'd say November. So round 2076 is the answer. Wow, I think we're done. Okay. Whew. Thank you very much, guys. Have a great day.